today's session on cloud database adoption and with an overview kickoff by Snowflake. Thank you all for attending. We got a good turnout today. Just a quick housekeeping is that you can update me or send any feedback to me at the email address on the screen if you'd like. Our roundtable discussion format today after the Snowflake short presentation will be an informal discussion. Anybody is encouraged to ask questions. Your anecdotal experience, stories, nightmares, anything like that that you've experienced are all valuable because we're trying to learn from each other's mistakes rather than having to make them all our own. I would ask that if you're participating for the first time, when you start your first feedback, please just announce your name and organization and maybe a little bit of status. Are you just curious, or have you tried there, or have you given up on it, been there, done that, moved on, and what platform you're on if you are experimenting at this time. So with that, I'm going to turn it over to Travis. Well, actually, one second. I'm going to, I put some sample discussion questions together to kick us off. I don't really want to walk through these. I'd like it to be more open forum, but I think that first question is kind of summarizing the cloud offerings in the data space. I think that's probably something that's valuable to the audience. And so I just put together a couple slides on that. Really, we have the big three cloud service providers, Amazon, Microsoft, and Google. And those are the platforms on which most of the solutions today that are cloud hosted are hosting on those platforms. So with that, there's several cloud solution offerings out there, one of them being Snowflake, who will present to us today. Of course, Microsoft, Amazon, and Google each have their own set of products that run on their own platforms. Snowflake runs on all three. We've got MongoDB in that space as well. And then you've got at the bottom of this, all of your what would you say, legacy database providers that have all have some type of cloud offering in the mix. And I'm not that experienced with the cloud offerings of most of those in that bottom half. And so don't by any means take this as a all-inclusive, comprehensive list of the capabilities of any of these platforms, but this is my little matrix that I keep for myself, and I thought I'd go ahead and share it in case anyone thought it was valuable. So with that, Travis Nortel with Snowflake, I'm going to defer to you, Travis. You can go to screen, and I will promote you.
Great, thank you, Mike.
Okay, you should be able to present now.
All right.
I'll stop sharing. So while Travis is getting ready here, please be thinking of, writing down, or putting in the chat format here your questions, either for Snowflake directly. You can certainly ask questions about Snowflake, but your general questions or comments that you might have, feel free to start using the conversation for that. And I'll present, if you'd please advertise who you are, what organization you represent, and what your current cloud status is in your organization. I'm not seeing your screen, Travis.
Yeah, it's not letting me. Give me 1 second. I'm gonna try and share the full screen here. Let's see if
okay. Something we probably could have tested.
And if I'm not sure if I'm able to, if I'm a guest. So let me.
Yeah, I'm just going to toggle you on and off. Make you a presenter again, because actually ahead of time I made you a presenter, but maybe that's not quite. Well, I toggled it again just to make sure. So you should be able to present from your desktop.
All right, let's try this one more time. All right, might still be on my end, Mike. I just emailed you the slide deck. If you don't mind, you can just bring that up.
Will do. Okay. There's more than one way to skin that cat. And I'll try to be quick with moving through the slides for you. So, can anyone see that Snowflake presentation there?
Yep.
Great, thank you. All right, thank you everyone. Happy to be here today. I'm going to just give a quick intro to Snowflake, a little overview of some traditional architecture compared to what we're seeing as a modern architecture stack with Snowflake. And then just do a quick overview of the difference in architecture builds from a Snowflake perspective. First and foremost, you have a couple of different attendees from Snowflake with you today. And as you see on the screen here, Kelly Hubble and Dawn are joining us. And then I'll give a quick introduction for myself. So I have been a sales engineer here at Snowflake for about 3 months. And prior to this, have been a client as well as a partner. So I come to you previously as a database engineer at a company called ZoomInfo, previously Discover.org, setting up their Snowflake environment, and then more recently a solution architect at Slalom Consulting. So I'm happy to be here and gonna now walk through some history of Snowflake. So Mike, if you can jump forward 2 slides for me, please. Thank you. So just a quick overview of Snowflake's history. So founded in 2012 by some industry veterans. So we have experience coming from Oracle. Really, our founders were tasked with taking one of the on-prem databases that they were working on from Oracle and were asked to create it as a cloud-based offering. And so what they found was this was going to be a full re-architecture for that technology, and they decided if they were going to do it, then they were going to do it for themselves. And so the idea of Snowflake was born. Over the next couple of years, quite a bit of development went in to that process to bring us to general availability in 2015. And from there, Snowflake has taken over as one of the leading cloud database architectures. And so formerly led by Bob Muglia, as some of you may know, who was one of the initial chief technologists for Microsoft for SQL Server. And so Bob led us through the next couple of years. And then we brought in Frank Slootman more recently, who transitioned over from a company called ServiceNow, as some of you may know. So that's just a quick background on Snowflake to bring us to today, which is we are servicing more than 4,000 customers across a variety of industries. We have quite a few, Kelly and I do as well, in the Boise area as well. I'm not sure who all is on the call, but hopefully some of you are here. And so, yeah, with that, let's jump into the technology side of things. So just a quick overview of kind of the timeline for what we've seen in terms of database technologies. Everyone has probably at some point in their career dealt with an on-prem database or EDW, something like a SQL Server instance where you're hosting and managing that system, tuning, partitioning, and really, babying that system into the needs that you have. The next stage of that was really the first offering of a cloud database. And really what that is the on-prem port into a cloud-based system. So, things like Azure's data warehouse, something like a Redshift would be more into this category of first gen or second gen cloud data warehouse. And then what we found was the explosion of data really started expanding the conversation of different technologies. So that's where data lakes were becoming more part of the conversation, Hadoop instances, where we really needed to bring in a bunch of different types of data and in large volumes to store them. And what you found then was you could do that, but it really wasn't performant. You didn't have easy access to the data. It didn't give everyone access to the data that they needed. And then really what we're leading into now is Snowflake is positioning itself to offer those as what we call a cloud data platform. So with that, I'm going to talk through kind of what traditional architecture looks like now, and then showcase how Snowflake is different in that sense. So this may look fairly familiar to many of you, and I have dealt with this quite a bit in my past life and experiences. The complex, disparate systems that are needed in order to put together an end product for the data consumers. So, we have quite a bit of problems that we see in this architecture in the terms of, we have siloed and diverse data. We're creating multiple copies of data in order to keep them performant, taking backups so that our system is not overwhelmed with historical data. And really what that leads to is complex, costly infrastructure, a lot of time in development, and then limited return on value, right? So you're waiting for your data consumers to be able to answer those questions. And really, it doesn't quite bode well for quick value insights that companies need now to make decisions. So, how does Snowflake differentiate itself? And if we can jump to the next slide, please. Thank you. So, I'm going to jump into a couple other slides, but I just wanted to showcase here that Snowflake positions itself as being able to handle all of those different types of workloads, and really, reducing the complexity of that tech stack. So being able to put different types of data, have multiple workloads run concurrently off of that same data source is really where Snowflake sets itself apart. And, we talked about what is a cloud data platform. And there's a couple of different key things that we look at that Snowflake considers important. And how we position ourselves in that sense. Can we jump to the next one, Mike, please? Thank you. So a couple of different requirements that we found over our experiences is one platform, one copy of data, many workloads. So reducing the copies of data across the organization reduces time to manage all of those. We can ensure that the data is fresh and up to date, and we can actually govern and secure that as well. So that next piece is actually the secured govern access. We want to be able to give people access to the data that they need, but also protect the data that needs to be protected. And part of that too then is the ability to perform at scale. As data has continuously expanded and companies are needing it more and more, different sources are coming in, those systems need to be able to scale with the business and actually help the business grow rather than follow along with the growth of the business. And so, when we're talking about a cloud data platform, it really should be something that the business leans on in order to gain insight so that they can actually help the business grow throughout its life cycle. And then the next part of that is that near zero maintenance. So, coming in as a software as a service, being able to have some of those heavy lifting features pulled off of the IT or data engineering teams so that they can focus on the value that they bring to the business instead of tuning and maintaining a warehouse. All right. And so the big question is, right, how does Snowflake do that? And what sets us apart is the architecture. So we talked about the different stages of technologies throughout the years of an on-prem, the first generation of a cloud-based EDW, and really Snowflake was built from the ground up to be on the cloud. So how do we differentiate ourselves in terms of architecture? First and foremost, we are cloud agnostic. So, Mike showed earlier that the table there of the offerings of what the different databases are. And so Snowflake is actually able to be hosted on any one of these cloud providers. And what we notice now is that a lot of companies are not singling in on a certain cloud provider. They're actually looking at multi-cloud deployments. Different departments are doing different things and have different needs that are handled better on different cloud deployments. And so Snowflake as a service is giving that ability to each person and each customer, regardless of size or cloud provider, is actually using the same tool. And that's something that separates us from other offerings. The next layer of the architecture is that centralized storage. So one of the requirements that we just went through was the ability to have a single source of data. And this is where Snowflake then has fully separated compute and storage. And what I mean by that is the data is not tied to those compute clusters. So the next layer here for the multi-cluster compute is where we get into multiple workloads, concurrent workloads, and then gives you the ability to actually scale those to the needs of that actual workload. And so previously we would have, I'll use Redshift as my example. You have to essentially right size your compute node for the workloads that you're expecting. With Snowflake, we actually give you the ability to scale those resources up, down, or out in terms of concurrency and need and size of workload. And those are all handled by you guys and gives you that flexibility to set those up for different types of workloads. And the last layer of our architecture is really the orchestration portion of this, is our cloud services layer. So when you're talking about software as a service, this is really where we get into reducing the effort from the management side. We're gathering the metadata, we're doing the pruning, and making your system performant so that you're not spending time having to go in and do that yourselves. And so this really is the four major layers of the Snowflake architecture that sets us apart. All right, and so what does that mean? Really what that leads to is some key business benefits that we're looking for, right? So faster time to insight, you have that single source of truth, you have a way to know where your data is, and your other business users can know where to find it rather than trying to find all the different copies, or someone's downloaded something somewhere else, or we've taken a data mart for this specific workload, but it's not getting updated at the same time as this other data mart. Right, so the ability to have a centralized location for data. In addition to that, one thing I didn't touch on was the ability for different types of data ingestion. As we move more towards click-based data streaming, Snowflake gives you that ability to store and analyze semi-structured data with SQL. So things that other cloud data warehouses aren't providing is that ability to query something like a JSON or Parquet with native SQL. So that again gives you those quick time to insights, so you're not having to pre-model data as it comes in or manage a separate data lake somewhere else. And so that was the quick overview. I know we had just about 10 minutes to get through that. I went through quite a bit. I wanted to give a couple minutes for questions, and then I'm going to turn it back over to Mike to start the roundtable.
You might be muted. If you have questions, remember to unmute yourself. You can submit those verbally or via the chat room. And just one quick reminder that we are being recorded. I hope that doesn't cause anyone to not speak up. I'd like the discussion to be quite open. I'll kick it off, Travis. So your your last point that you made about having a sort of a ubiquitous integration between perhaps your text document type data, your semi-structured document type data, your text unstructured data, and your structured relational data. That's something that's kind of unique to your product.
Yeah, it definitely provides a lot of value for customers who have been trying to get at some of the data that is either, we talked about the Hadoop or data lake instance, right? Mm-hmm. It gives that ability to, again, bring your data into a centralized location so that you can do the analysis or find other common themes between data sources. And you can have a completely unstructured data set, and you can also have your dimensional model or data vault model inside of Snowflake and be able to actually combine those data sets together to gain insight.
As powerful as that sounds and is, and as unique as that is, any of that text data that's still in text format, emails, contracts, those types of things, do you have capabilities for natural language processing on that?
So natively within Snowflake, no, but we do, we have started to offer what we call external functions. And it really is that extensibility of giving those teams, the engineers or the data scientists who are working with other AI ML tools or other APIs that they want to leverage, is the ability to lean on those cloud providers and actually create those functions outside of Snowflake and then call them natively within Snowflake.
Okay.
So we're moving into the space where that extensibility feature is really providing a lot of value from Snowflake's perspective. So you are, again, not having to reach out to other systems and having to bring data out of your warehouse or your lake at this point in order to do some of that analysis.
Yeah, good stuff. Basically make metadata out of your structured data using some other tool externally, store that metadata, and then use that to integrate your text data with your big data, Hadoop, or the NoSQL data, and then also your relational data. Kind of pulls together all the options within one platform, so to speak, right?
Yep.
What other questions out there? Okay, I think we have one coming in on the chat. Shane says, towards the beginning, I believe it was mentioned there was some capability that Snowflake can perform data munging or cleaning, which alleviates some of the time required to analysis for the data engineers. Is this something that's done through AI ML through Snowflake? What kind of scale is applied to the new data, new relationships entered in Snowflake? Or is his understanding need to be corrected, I guess?
So no, Shane, there's a couple of different parts to your question there. And so the first is in terms of data munging and cleaning, right? What we're seeing now is the transition from a traditional ETL to an ELT. And so, when we're talking about doing that cleaning or munging is, we see a lot of customers that are just loading their data into Snowflake and doing the transformations, the analysis, the schema understanding and building within Snowflake. The AI ML piece, right? If you still want to run models on those types of things, you're going to have to integrate those with your data science tools. The extensibility features that I was talking about actually help augment that in terms of you can keep your data in Snowflake and reach out to some of those things. But in terms of running, actual tests and getting your models run, you would still need to use your AI ML tools. But we do partner with quite a few, including something like SageMaker, Dataiku. So there's quite a few different tools, and we also offer connectors for pretty much any way you want to connect to the database: ODBC, JDBC, Python Spark connectors. So the idea is that you keep data centrally located, so that you're not having to manage them in different places.
In my experience, the last thing you want to do is take the data out of the cloud, crunch it, and then put the data back in the cloud. You'd rather take the logic to the data. Anybody else have experience with this, the legacy ETL versus the more modern ELT approaches? Anybody want to speak up about their experiences on that?
Yeah, this is Mike O'Toole. I'd be happy to speak to that. So I'm with ClickFunnels, and we're currently using Redshift. I think what's really interesting, we are taking the ELT approach, and since we are a basically 100% remote company, we really have no choice but to leverage cloud technologies for all of our data warehousing needs. So what we've had success with is using tools like Segment and Stitch to connect to our third-party applications like Zendesk and Stripe and Facebook and Google Ads, things like that. And that's been really seamless just to pull those in. But we've really struggled just pulling our own application database, which also resides currently in AWS in Aurora. That's been our biggest challenge, is actually getting that data just extracted and loaded into Redshift. But I think that has more to do with that we've outgrown our application database. And so it's very fragile. It's tough to add the right indexes. We would love to look at something like binary logging, because that really seems like it's a real silver bullet for, extracting and loading Redshift. We are not able to apply that right now because I think our downtime would be too great and too impactful to our users. So right now we're just sort of, just getting by, getting as much as we can over in there. But overall, that's the strategy. Tripped up by the data that we actually own.
Thanks, Mike. That was good. Anybody else? Any other general questions or comments? Okay, Travis, did you have anything further?
I don't, no. Happy to answer questions as discussions come up in terms of Snowflake, but excited to be here and hear how everyone's kind of approaching their cloud data warehouses and moving into the cloud. Thanks for having me.
Yeah, thank you for that overview. I think that'll get the rest of the discussion going well. So again, just in this roundtable format, if you just please announce your name, as Mike O'Toole did when he interjected there. Name, your organization, and what's your current status? Are you curious, or you've already tried it, and what platforms you've worked on? So with that, I do have a few questions that I put together as like sample discussion questions. But before we dive into these, I'd like anyone else to bring up anything that they've had on their mind, whether it be a question or whether it be a comment. So we'll just pause for a bit and give people opportunity to dive in here.
Mike, this is Mike O'Toole again, not to take over the conversation, but I'd be very curious to hear what strategies people are trying to employ in say, a similar situation to us. How are they getting their application database data into a cloud platform? What successes they've had? What strategies are they using? I'd love to hear from other people.
Is there anybody else that's on the cloud that would be willing to share their experiences with moving data into the cloud? Maybe the processes, tools, what failures? That's maybe as valuable as anything is what didn't work. All right, there's 20 people on. It's a roundtable discussion. Don't be shy.
I'll talk. I'm not shy. This is Caitlin. So what's funny about a lot about our cloud work that we're doing and moving towards, we actually have ran into a lot of issues, not even in the technology space. A lot of our pushback is actually on the legal space, on getting things over into the cloud area. I would say we have done some stuff. We're playing around with Azure and AWS, but I think that typically, at least my organization, has been our biggest hurdle. It feels like is getting the other spaces comfortable with the fact that they're putting quote data out in a cloud environment, right? Especially because we have PHI, et cetera, other information. So I know that's not necessarily technical related to this conversation, but that's our hurdle right now.
Yeah, that's been one of the major hooks that I've seen as well. I'm aware of one organization, now this has been 5 years ago or more, that went to the cloud and then backed off of it. They took as much time getting off of it as they did getting on because of those security concerns. Now, 5 times is an eternity in terms of how technology is progressing these days. And I think most of those concerns have been resolved from a technical perspective, but there's still that catch up in the industry of businesses and organizations being unwilling because of the horror stories they've heard. So interesting, we have the question here, what barriers to cloud adoption still exist? Well, absolutely, security concerns exist out there, but maybe the question is, are those real or not? Have we moved beyond that in the cloud space? Does anybody have thoughts in that regard?
Hey, Mike, this is Carol Carden with Snowflake.
Hi, Carol.
Hi. How are you doing? I work with the rest of the team, but I only focus on healthcare. So Caitlin understands the pain that you're going through with that. And it is the ongoing conversation, but we've seen that with the pandemic and the virus and people having to do more remote work, that there has been a bigger push to the cloud. And it just requires a lot of education and time to work through the concerns and convince people that the security is there and that the certificate, and that you're choosing folks that have the right certifications, working on, selfishly, Caitlin, like you, I'm focused on healthcare. So HIPAA, high trust, and those types of certifications around that. But it's not an unknown challenge, but we're starting to see the shift in the marketplace for that. It's not a fast shift. It's a slow one, but it's happening.
Do you have it, Carol? Maybe you're not the right person to ask, but do you have horror stories at all?
What kind of horror stories do you want, Mike?
Well, in terms of what lessons have been learned, the hard lessons. We went to the cloud, we lost data, or we found that there was some vulnerability, and then what's been done to correct that in the industry?
I'm probably not the right person to answer it because, I'm going to be coming at it from a Snowflake perspective about what we've done and what I'm doing specifically with our customers. Hey, Snowflake team, is Don Phillips on the call?
I'm here.
Okay. I think Don might be able to add some color just from his background of having been a customer and what he's seen, and then what he's seen in his almost 5 years at Snowflake. Don, did I just chunk you under the bus?
That's okay. It's all good. That's what I'm here.
Okay.
Yeah, so it's interesting, and to kind of give a little more detail to my background. Before Snowflake, I was actually director of data platform for GoDaddy for a period of time, and prior to that, did about a 7-year run at T-Mobile in kind of the data space. And it's been interesting if I go back to where the cloud was and what we were dealing with and trying, even back in my T-Mobile days. It was we'll never go there, and there was a lot of legitimate security things, and there were some, there's certainly been, and I'm not going to call out any super ugly specific things, but there's been plenty of incidents of misconfiguration. But the truth of it is, right, nothing is 100% secure. We all know that. And really where things tend to fall down, if they're going to fall down, is in human error in the configuration and setting up that security, which is not typically an easy task. And I would say across my history, that's been a common theme, right? And oftentimes, thankfully, those were minor issues that were resolved, but the potential is always there. And I think what's happened over the most recent years, and selfishly, I'd say Snowflake's done a really good job with this, but there's others out there. It's not just us who've done a really good job of making that more straightforward and more familiar to those of us that didn't grow up in a cloud world, and really try to take some of the human error factor out of that have made things a whole lot better. And I think one of the key parts for me looking at this is you really want to think long and hard about what is the background of the system, platform, whatever that you're putting out there into the cloud. Was it started here and therefore this cloud security stuff has been there from the get-go, or was it bolted on as an afterthought? And I think that's a super relevant thing to take into consideration. But like Carol, it's been interesting. When I came to Snowflake, which is about 4 years ago now, 4.5 years, the cloud was completely new. We were, the fact that I ever thought I'd get a healthcare customer or a government customer or something of the like into a public cloud was unheard of. But the tide is definitely changing. So that was a lot of words. I'm not sure it was super helpful, but that's kind of how I've seen it.
Yeah, thanks for pitching in there. I think, man, that the human error element is certainly probably the largest risk. The technology really has this ability to be able to manage who has access to what data, even down to the cell level. We've presented in this same forum on cell level security within a relational database, and it's technically possible. The question is, can people administer it correctly? So, where do you spend your time? Do you spend it training your people or trying to catch up with the technology? And sometimes that can be a difficult race. But I would also add, you're up against those problems whether you're on the cloud or not. In other words, here's a horror story. I got a mailer from Chase Bank this week that said that my data may have been compromised because their hard drives weren't wiped before they were decommissioned. And so they have an on-prem solution, obviously. And when they decommission their data center, that data may have been compromised. Well, so that this problem isn't new to the cloud. It isn't specific to the cloud. And it made me think, who would I rather trust? My organization to manage the hard disks and the data centers and all the info security vulnerabilities, or would I rather trust someone whose job it is to do that on a massive scale, like the AWSs and Googles and Microsofts of the world, and then employ a solution that's built for that environment? And then I get to focus as a developer or BI professional or data professional. I get to focus on just managing the access and not worrying about who's infiltrating my data center. So that's just a thought that I had, and that was a real horror story that came through just this week. That mailer from Chase. Maybe others got that too.
Hey, Mike, this is Mike Planting with ClickFunnels.
Hi, Mike.
Hey, so just a general question for the group in regard to the organizations that are 100% cloud-based and that have maybe come from Microsoft SSIS background. How do you orchestrate ETL jobs in the cloud? Right now, we are, like Mike O'Toole said, we're pulling data from different sources like Segment, credit card processing, landing it in Redshift. And that's done through Python, orchestrated via, used to be orchestrated via Airflow and coordinated that way. We use another platform called Celery, kind of a task queue system running on an EC2 instance on AWS. But I was wondering if anyone has or is using a more streamlined tool that's 100% cloud where they can just orchestrate it from, let's say, a browser.
Yeah, good question. Anybody?
Or even just to add on that, sorry, this is Mike O'Toole. Is anyone from Snowflake familiar with how their customers are orchestrating their data once it's already landed in Snowflake?
Yeah, this is Don again from Snowflake. We do, and there's a good, I would say, variety of it if we look across our customer base, right? We have, I heard a couple of them already called out, like, we do have a number of customers using Airflow. We have a number of customers using Azure Data Factory, Glue, and a few others that are cloud native. I would also say that we have a lot of people similar to you guys mentioning Stitch and those, right? We have a lot of people that are looking at the newer kind of cloud-based, whether it's the Matillions of the world or similar tools out there to orchestrate and build all of that. So it's and you contrast that with there's still certainly the people out there doing their own, what I'd call homegrown, right? Where it's that they've chosen to go down the route of using basic schedulers, putting them on a VM or an EC2 instance out there, and building those out through scripts. So, I think that's, if I looked across our base, that's kind of the lay of the land, and it has to do a lot with where the data is coming from, right? Are they still in a hybrid mode where there's a bunch of on-prem data that they need to get out into the cloud? Are they 100% cloud native? Yada, yada, yada.
Thank you.
Anybody else have stories they'd want to share about their data pipeline orchestration? So the guys at ClickFunnels there mentioned some of the Python and Airflow capabilities they're using, and several of us have experience in the data automation forefront, which I don't know if you'd consider, I don't know who you'd consider this pioneer in that space, but there's been several companies who've come up with these templatized, automatable, metadata-driven approaches to ETL, and I've become a firm believer in that, which is instead of hard coding or hard coding, whether it be with an ETL tool or with a Python or any other language, rather than hard coding your ETL or ELT, as much as possible generating that from templates and metadata. So you basically build metadata for your lineage and then leverage that metadata to generate, based on the patterns in your data pipeline, generate the code, and then orchestrate that through a scheduler. Some of these providers offer schedulers, others rely on some enterprise scheduler. But I found that to be very effective, and the quality goes up tremendously when you start using those templates, because you eliminate that, what was referred to earlier as the human element, the human error side. You eliminate a lot of that when you generate your code, as opposed to hand coding your ELT.
Yeah, and Mike, this is Mike Planting again. We've kind of gone down the homegrown automation path. We've basically developed a lot of store procedures to execute different data vault objects. Go through the whole process of loading up stage, hubs, links, satellites, materialized views. But the chat, well, it's no longer really a challenge, but I would like to find a more seamless way to orchestrate the execution of those templated, automated stored procedures, rather than going down the Airflow, Python, Celery road. It's working fine now, but I would like to find something that's I guess more supportable in the long term. And that's why the question went out to the group is the orchestration is a bit of a challenge.
Understood. Any other contributors out there?
This is Travis from Snowflake. I'll just add a tool for you all to check out in terms of kind of creating that code, not necessarily the complete orchestration side of things, but some of the founders from Stitch created a tool called DBT, which is open source. And we see that used fairly often in the industry.
Mm-hmm.
So definitely something to check out.
Yeah, we've looked at that as well, and that looks like an incredible tool. One of the challenges I noticed with DBT Cloud is, well, at least I looked at a tool called DBT Cloud, and it's great for working from a view perspective after the data has been landed via extract load or ETL, but it's more focused on after you've built out your core structure, let's say your data vault, your data warehouse. DBT seems to build on top of that. And so like not great at transformation, but great at data modeling. But again, I may have a limited experience and insight into that tool, so maybe it does more.
I think I've seen it so far used for primary that aspect, Mike, but the way that it's developed in the sense that you can actually write your own SQL for all of it, I wouldn't see why you wouldn't be able to do the transformation side of things. Querying the information schema, getting ideas of what that looks like, and then building out some of the other aspects of it. But then that brings into the discussion more so the orchestration side of things, right? Making sure that it's stepped through in the right way. So there are still some challenges, but definitely a great tool for everyone else on the call to look into as well if they're interested.
All right, thank you.
All right, any more comments around orchestration, ELT, or anything in general? Any new questions? Anybody that is just in the curious phase out there, what barriers are you up against? These day and age, everybody's up against the cost barrier, right? Seems like a lot of companies are in cost containment mode right now. What barriers out there to exploring the cloud are you seeing?
I would say, in addition to the cost, this is Caitlin, by the way, from Blue Cross. I would say kind of an ROI, right? Hard savings and why we should move there. It's easy to say it'll be more efficient. But when you're talking about costs in general, that's a question that comes up, right? Just based on how everything is set up today versus going to the cloud. That seems to be an ongoing conversation on what makes sense to move to the cloud and when and where.
Yeah, maybe clarification on that would be, is the cloud actually saving money as opposed to your on-prem database administration, right? And you're paying per use versus hiring a DBA and running it in your own data center. What is that actual savings? We've all seen the numbers advertised, but does anybody, I know we're getting into probably some numbers games that might, not appropriate to share online, but does anybody have actual stories of, hey, we did this and it wasn't as affordable as we thought, or it saved us X amount on our bottom line, and we're glad we went there? Is there anybody on either side of that coin? Don't be shy. So while people are thinking through that, I did read an article last week. I think it came out for the Institute for Analytics Research, and they said, how has COVID changed the life of data professionals? And one of their points was, all projects are being called on the table to justify their ROI. So you mentioned that, Caitlin, so it made me think about that article. Is if we have to justify our projects, or maybe even our existence in the organization, by our ROI, it's oftentimes hard to measure either side of that ROI calculation. In my opinion, from what I've seen, the cloud makes it a little easier to estimate the costs, because you have a per use fee-based model, and you can actually allocate connections to certain departments, so you know exactly how much your research and development department or your finance department or your procurement department is using, because they're connected and you're monitoring and paying for exactly their use. It's a little harder to allocate the data storage use, but that's usually a small portion of the overall cost. So their point was, you've got to justify your ROI. And my conclusion was, well, maybe the cloud helps you at least with the cost side of that ROI calculation. Anybody care to disagree with that? Or agree? Or just let us know you're alive? Well, we are running right up on our time barrier. So I guess one more call. Any new questions, any new comments in wrap up? Okay, well then I'm going to end the recording and make it available out there on the YouTube channel that we invented last month. If anybody has objections to that, let me know, but that's the plan at this point. I'd like your input on the roundtable format. I'll just be honest, I think, I appreciated everybody that pitched in today. I think, in the future, I'd want these to be even more interactive and, have participation from the majority of the group. So I know there's others on here that have experimented in this realm, and I would love to have heard from everyone. But thank you for those who did participate. Thank you for those who listened in. I hope it was useful for you. Please send feedback to me. It'll probably determine whether we do anything like this in this format in the future versus our more traditional presentation format. So with that, thank you for joining today and for the helpful discussion.
All right, thanks, Mike. Appreciate it.
We'll see you in September virtually. It's going to be on the 10th, not the 3rd, in September. I hope that's not a problem for anyone. Take care.
Thank you.
Best regards. Thanks, Snowflake. Thanks, Travis.